This conference will now be recorded.
Hello everyone, welcome to our day 22 in our GCP Cloud Architect training. So yesterday we talked about basically about the background. Uh, yes, Deepak, you are not able to hear me. Folks, you are able to hear me or not? Okay, awesome, thank you. So yesterday we discussed about firewall rules, basically using firewall rules, use firewall rules. Sorry. With the help of service account, apply a firewall rule is something which we saw. And we also started exploring about the shared VPC, which is going to be very, very important in your real implementation. I'm not sure how much it's going to be helpful during the exam, but in your real implementation, that too, if there's some Googlers involved, definitely they are going to talk about this. And if you are submitting any solution proposal to a customer, and that customer has an on-prem infrastructure that is getting migrated to GCP, definitely this is going to come into picture. The shared VPC concept is definitely going to come into picture, at least the basic version of it. There are some different flavors of it, hub and spoke model, all those things. So that's the advanced level which people will think usually in network engineering training. So for our understanding, the shared VPC, what we saw yesterday is good enough is what I feel. And we also saw about some of the limitations or limits, few things which can be increased by contacting the Google sales, and few things cannot be changed. For example, one service project can only connect, a project can only connect to one host project, simple. So it can be only one service project only. A same project cannot be connected to two multiple hosts. That is not possible is what we had seen. That's a technical limitation. So with shared VPC, what we saw was basically it was centralized. It was completely centralized. So you have an issue with firewall rule, go to your host project, VPC, and turn on your firewall rule. If you want to add a new project, attach a new project, go to your host project. Whatever you do, you always do it in your host project. It's centralized. So whenever it is centralized, you will always know the drawbacks of it. So could be a single point of failure if somebody deletes the entire project or somebody does something. That could be one problem. The other thing is that your team may have some good amount of networking skills. So even for small port opening, you don't want to raise a ticket. For example, in real implementations, right? When you basically have the shared VPC setup, if you want to open up some ports, you are having an application running, you want to open up a port, in a large organization, it's going to be an IT ticket which you need to raise. It goes to an operation team. They see it. It first gets approved by a manager, super boss. Then it goes to this IT team. They will do it, which they will do basically in the shared VPC. So it's going to take time. Sometimes I have seen myself uh, with these things. What they are doing in on-prem, they do the same thing in GCP. The delay, everything comes again. So it should be faster, but because of the too much of process added, I have seen many organizations, especially banks. So it becomes too much. And I had seen one of the previous learner in batch 5 took almost like 4 weeks to just create a Kubernetes cluster to get all this access. So he is in offshore, and the ops guy is in different country. So one day it still gets over just because they communicate in two different zones. So that kind of stuff can happen. To avoid that, if your organization or if your team is little comfortable with networking concepts, you can play around with it at least in the development environment. If you want to do it, uh, to avoid all these hurdles, you have an option called as VPC network peering. So what does this do basically is the same concept. What you saw yesterday was two service projects. If they were to communicate each other using internal IP address, you use shared VPC. So for that, you need to have an organization node. You need to enable certain specific permissions at an org level. Only then you can do it, right? Now, if you have two GCP network, simple. I can easily peer them. So what do you mean by peer them? Basically have a bridge between these two networks so that the instances can communicate, or Kubernetes cluster can communicate between each other using internal IP address. Simple. So that's what is basically your VPC network peering is all about. So, but the most important thing, many learners get confused. Whenever you hear the word VPC network peering, it is only GCP's network, folks. No on-prem, no AWS, no Azure VNet. So the other cloud network or on-prem network will not even come into picture. VPC network peering only works with GCP's network, the global network which we have been seeing so far. That is the only network comes into picture. So this is between two GCP networks which can be in the same project. What do you mean by two VPC network? For example, so if I go to my batch 6 project, so even today we are going to discuss more about VPC. So what I'm going to do is, for easy accessibility, I'm just going to pin this. So if I go to VPC, so we have three networks, batch 6 custom VPC, default, and VPC Taiwan. If I create a VM in one VM using this VPC, in maybe one of the regions, and another VM in Taiwan, these two are two networks, but they are in the same project. Two VPC networks in the same project. If you were to communicate each other between these VMs using internal IP address, always its internal IP address is the focus, then VPC network peering is going to come. So I have seen some of the articles just mentions VPC peering. It's not a better way to use that. Always use VPC network peering, because there's one more peering product which is going to come, which is going to make you confused. So stick on to the right name. So VPC network peering. So between two VPCs in a same project. Good. Across two projects. The moment two projects comes, the VPC will definitely be two networks. So it is understood, meaning I create a VM in batch 6 in this VPC. I have another project called as project 2. I create a VM in VPC Singapore. For example, I create a VM in VPC Taiwan in batch 6. I create a VM in project 2, which is going to use VPC Singapore. So two different projects, two different networks. If they were to communicate each other, again VPC network peering comes into picture. And both of these projects basically are under my same account, batch 6, project 2. Both are under the same account. That's okay. But what if I have across two different organizations? So that is where a cool feature comes into picture, where you can have something like a SaaS offering, software as a service. What is that basically? So let's try to understand this. So I have company A, who specializes in websites. They build very cool websites. I have another company called as company B, or organization would be better. Organization A, and I have organization B. They specialize in machine learning. Now, these days, every website is going to have machine learning capability in some or the other fashion. Now, if you still stick onto the old traditional way of building a website, and it's not going to sustain. So what organization A does is, they don't have a skill set in their organization. There is only web developers. They only have web developers. No data scientist. No data scientist, have only no data scientist, nothing related to the machine learning stuffs. Okay, they don't have it. Now if they want to make their website AI driven, there are two options. Either hire a data scientist who's going to get the highest salary in the organization, basically, because that's a really a cool job. So and I heard that it is the sexiest job of the 21st century. So it's going to be definitely expensive. Then build the skills, then make their website AI driven. Option one, which is going to be little time consuming because procurement, like the hiring process, all those things is going to take. The second option, what they can do is they can just do a tie up. So they can have an agreement between A and or B. They can do an agreement. Can you give us your service? So maybe they have built an application, a service, something specifically. Maybe when you upload an image, it's going to find something what's there in that image and do something. So it's going to be called as argb dot something like this. APIs dot argb dot com slash some awesome awesome ML, something like this. They have an endpoint. They have an endpoint. So you can, if you purchase their subscription, they are going to give you the details about how to use this. They are going to give an API key, some credentials. So you put this API key in your in your web application, in org A application, and start doing it. This is option two. So option one, uh, hire a data scientist. I'm just going to call this as DS. This is option number one, which is going to be long process. Option two, buy org B's subscription or API subscription. This is good. No work, just use a API. That's good. Now, after they start doing some interaction, they come to know that, fortunately or unfortunately, both org A and org B has their entire infrastructure. Both are startups for our simplicity reason. Both have their entire setup. This api.org one, oh, sorry, orgb.com. This itself is actually hosted in GCP. So if both are users GCP, definitely network is going to come into picture. So they will have org A VPC, org B VPC. Just peer it. If you peer it, what's going to happen is you don't need to use this kind of an API. You may directly use an internal IP to access it. So that way the latency is going to be little less, because if it's going to be an API, it's going to get routed over internet. So and more egress cost is going to be there. So we'll talk more about the networking cost soon. So if both organizations uses GCP, the better option is VPC, network peering. This is going to be a option. Now this is where you are having a software as a service. So this is a software which they have. You're using it as a service which has been enabled. So this is between two different organizations who's using GCP. Is this part clear, folks? Whenever two different organizations both using GCP and you want to basically have a connectivity between them, this could be an option. So let me just save this. Sometimes only during the training some good content comes. Okay, so this is the option which you are going to do between two different organizations. So but the underlining stuff, if you see, everywhere it is the same concept. GCP network, two different GCP network, it works simple. And because it is two GCP, two networks, right? The entire traffic, right, does not rely on any public internet. It only travels between the GCP projects, meaning it uses Google's backbone. I'll show you this demonstration after the explanation, which is really a cool thing which you can see basically. So the traffic is going to be completely on GCP. So it's not going to use the public internet. And the last thing is the limits when it comes how many such networks you can do peering. So you can peer with 25 such networks. So VPC1, it can peer with VPC2 till VPC 26. So basically this many 25 VPCs, what each VPC can peer with 25 VPCs basically. So that's a limit. I feel it is a upper limit, or it's a technology limit is what I feel. So I need to look into the documentation. It can be increased or not, but by default it's going to be 25 VPCs is what you get as a limit. And you have a detailed page usually, right? The documentation is really good. So, and in particular, one documentation which is really helpful is any products which you learn going forward, right? Always look at so most of the trainings, including the one which I do, I usually say or the other trainers or other course material says, what is this product good at? That's always good to know what is the product good at. But there is a specific page in GCP for every product called as limitations. So where is the product you should not use, or what are the limitations of it? So if you know that limitation, right, your architect skills becomes very robust. For example, if I just do GCP VPC peering limit, you'll get a nice set of this thing documentation where limits, what it can do. Basically you are going to get that limits basically. So looking at this kind and this is not going to be helpful for your exam basically. It should be basically, if I search for 25, yeah, maximum number of connections to a single network 25. This is what I just given you not even the tip of the iceberg. It's just an entry point. I just mentioned one liner. So whenever you look for this quota and limits, this is going to work very well to get a better understanding what is this product has, where this product does not work, the limitation. um, many in many trainings they don't emphasize it, but only if you know this limits, you are going to build a better solution basically. So that's one limit. And the last important thing, which is very important, and because of this nature only, we will use some alternative products in the future. uh, Transitive in nature, non-transitive in nature. So what do you mean by non-transitive in nature? Simple, go back to your arithmetic class which you did in your school days. So uh, in arithmetic, if I'm not wrong, if A equal to B equal to C, uh, then answer one of the thing which you do is A equal to C. This is what you do. This is the normal thing which we learned in our school days, right, in arithmetic, the transitive law. So there were three laws: transitive, distributed, one more thing I don't remember. One more thing was there. So uh, this is transitive in nature. So if you apply this to your modern world, which is your Facebook, all those things, Mahesh friend is going to be uh, F1, and F1 has a friend called as F2, which means Mahesh and F2 are mutual friends. I'm not so good at Facebook, but this is my understanding, folks. They can do. So this is what you do even in your social media, right? Mutual friend concept. So this is not going to apply to VPC network, meaning that is where this diagram comes into picture. So you have network A, network B, network C. Now network A and network B are peered. You see this? They are peered, meaning network A and network, and this is done at a VPC level, folks. This is done at a VPC level. You don't do it at a subnetwork level. So if you see the shared VPC, you were sharing actually the subnetwork, not the entire VPC. So here the entire VPC is going to be peered. So not at a subnetwork level, it is at a VPC level. So the moment you have network A and network B, the subnetworks which is going to be there, they can, and the VMs which is going to use those subnetworks, they can communicate using internal IP address. Similarly, network C and network B, they are peered. So the same example, A and B are peered, B and C are peered, but it does not mean C and A can communicate each other using internal IP address. They are not peered. You have to explicitly peer it. So that is non-transitive in nature. So you have to peer every network if you want. And you may ask, so what's a big deal? Let's peer it. But you have a limit, right? 25 stuffs is what 25 network is what you can peer. So you cannot simply keep on peering everything. So, and also there's going to be an overhead of maintaining those things. And this peering or VPC network peering is totally going to be free of cost. There's no cost for this because everything is on Google network. You just peer them, basically have a route, and it's going to start working. So let's see a demonstration, folks, where we will see basically between in the same project two networks, uh, between two projects we'll see. Between two organizations we cannot see because I don't have two different organizations. So there's one question, is 25 network at org level, right? I don't need an org level itself. I don't need an org level. So this is between a network. So if I just do VPC network peering limits GCP, sorry, this is per project is my understanding. The maximum number of network that you can connect to a given VPC network using VPC. So that is nothing to do at an org level. So it is at a project level. Oh, sorry, to be specific, at a VPC. That's it. Kumar. So hope that answers your question. So it's nothing at an org level. There could be some restrictions at the org level, but the 25 is at a VPC. One VPC can peer with 25 such this thing.
So Mahesh, if I have at my organization, if I have 100 projects, everyone is using GCP. So project 1 and project 100 can connect with peering, right? In that case.
Possible.
Okay. Okay. Thanks.
And say, for example, project 1 has something very cool feature, and project 100 wants to use that in their project because it's under one organization. They can open some certain stuffs basically. And this peering is going to help in some easy form. For example, coming back to this software as a service option, right? So because both organizations are using GCP, they use peering and start doing it. Now, month 1, let's take the most a possible scenario. Month 1, org A paid the bill. So it's going to be some billing required, right? Paid the subscription or paid the bill, working fine. So month 2, there's some issue in the organization. They have not paid the bill. Now you as organization B does not need to go chase them. When are you going to pay the bill? So simple, block the IP address, not paid. So in org B, block the IP address of the incoming source, which is organization A's. That's it. They'll automatically come back and pay the bill. Simple. The traditional model which most of the telecom vendors and all do it. So something simple. So that's the easiest part here. You have more control between the network. So there's one more question. Can you please explain again non-transitive nature? Okay. Non-transitive, basically the word transitive means is simple. going back to arithmetic. So if A equal to B property wise, B is equal to C, then as per transitive law, what it means is A equal to C. This is the normal understanding of a transitive stuff. But when it comes to GCP, basically the VPC networking network peering is a non-transitive in nature. So what do you mean by that? If there are totally networks like 3 networks, A network, B network, C network, A and B are peered. Then C and D are peered. So then it does not mean A and C are implicitly peer. No, there is always, it's not going to work. You have to explicitly peer it. Peering has to be explicit. You have to go and explicitly peer the networks. Implicit peering does not work basically. So A and C are not peered. So meaning they cannot communicate between each other using internal IP. They can communicate using external IP. That's not a problem. So that's not a problem, but they cannot use basically the internal IP, Mangesh. So this is what this diagram depicts basically. Actually, this diagram was taken from Google documentation, but they have removed that documentation. So some nice images they put, but unfortunately they remove sometimes. I don't know why. So this is what it is saying basically. And we'll see this demonstration, so don't worry. So we'll see our demonstration, then you should be able to appreciate network VPC network peering yourself. So let's do a demonstration. So first let's go with in the same project, two different networks, and let's see how it's going to work. And I'm not going to put firewall as a constraint going forward, folks. We know how firewall works, so I will make sure whenever we do any demos, the firewall rule to at least ping and SSH is going to be there. So okay, so we will use batch 6, and I'm going to use basically batch 6 custom VPC and VPC Taiwan. Okay, and the most important thing, whenever you are going to peer it or any networking concept which you are going to do, make sure there is no overlap, IP overlap. If IP overlap is there, what's going to happen? I'll also show you that also. So the peering will not work basically. So overlap or IP conflict should not be there. So this is one network, default VPC, batch 6 custom VPC is one network. It has 3 subnetworks. There's one more VPC called as VPC Taiwan, which is only in Taiwan with a different CIDR range. So nowhere the IPs are conflicting. Good. Now what I'll do is I will basically, this is a bug. Okay. Before I proceed further, right? So I'm not sure whether this is reflecting in your console, folks, but there has been some enhancement in the UI where compute, they have it something like this, and they have a specific section for serverless, which I really like, which shows products like App Engine, Cloud Functions, and Cloud Run. So where's that? CI/CD. They made it more specific to the use case. That was really good. You see this serverless products. And if you were to do some application integration, none of them we have talked yet. So this is possible. If you want to do some CI/CD process, these are the products, and we have used a little bit of them. I guess everything we have used. Cloud build, container registry, artifact registry, which is the next version of next generation version of your container registry, and source repository. So this could be helpful for CI/CD. So this is really a cool way of categorizing it, which was not there. It may not be reflecting in your this thing. Soon it's going to be rolled out. Basically, they have done a canary deployment. So just thought of sharing it with you. Let me go create a virtual machine. What I'm going to do is very simple. Create two virtual machines. Make sure they use two different network. Now, this concept you can use it if you are meeting a customer who's totally new to cloud, and it is more of little education required to them, where if they ask, my competitor is also on the same cloud, if I am also on the same cloud, is there going to be any kind of a data breach? Can the competitor see my data? If such kind of a question comes, very simple way of explaining them is, you can say, assume you have a network which you have created. This is your network, and you can treat this VPC Taiwan as your competitor's network. Let's go create a VM in these two networks using this sub networks, any one of them, and let's see whether they can communicate each other by default. And if I go to my firewall rules, the firewall rules allow, basically, this is for batch 6, ICMP and ping is there. Okay, I have to edit this. Let me make this. I'll keep it as open. You can literally show this demonstration to them. So the firewall rules are open. Taiwan, this is Taiwan's. This is the custom VPC. It's the same kind of firewall rules which we have. Now you can show, we can create, and it's in the same project. So if I create two VMs, one using batch 6 custom VPC and one using VPC Taiwan, how they behave is what we wanted to see. Okay, so create a VM and we'll use a template. So use a template. I'll call this as server SG. Then I'll leave all the things default. I'll leave all the things as default. Under networking, I'm going to do this one. Change. I will have 3 networks. I'm going to use batch 6. I'm going to see subnetwork Singapore, and I don't need external IP address. If you want, you can keep it. Slowly we will remove it at one point of time. External IP address, done. I'm just leaving the external IP address. Later we'll remove that. Click on create. Now by the time this comes, let me create one more in Taiwan. So I'll call this as server Taiwan. The most important thing which I'm going to do is, basically, under network, I'm going to use VPC Taiwan. I'm going to use VPC Taiwan. Create. Machine type is not important. I'm just going to remove that column. Okay, I have server SG, server Taiwan. So you can say server SG is your own VM. Server Taiwan is the competitor's VM. Now both are on the same infrastructure, GCP, and see whether they can communicate each other. So let me just SSH. So let's just wait for it to SSH and let's see whether they will be able to ping each other. IP space A. Now let me copy the IP address of Singapore server, which is going to be class A, class C, and the IP address of ping. Now, before I asked, Anil Kumar already mentioned the answer. So whether this is going to work or not, folks, two different networks, but they are in the same project, folks. They are in the same project. So will the ping work or not work? What's your thought? Anil Kumar already has the answer. Just before I ask you the question, Vivek got an answer, so that's correct. Kumar got it correctly. Others? Will the ping work, folks? Simple, nothing complex we are doing. Two VMs. All this time you used to create it in the same network. This today you created it in two different networks. So Anil Kumar, Vivek Kumar got it. So let's hit and see it. There's no harm. So as Anil Kumar, Vivek and Kumar mentioned, the ping is not going to work. Simple. These are two different networks. If these are two different networks, the route is not going to be there. The bridge is not going to be there between them, and that's the reason the ping will not work. Now, the solution for this in other cloud possible options are cloud VPN. Another option other cloud provides also is VPC peering, if it is in the same region or something of that sort. In GCP, you get the same thing. The first option which we are going to refer is cloud VPC network peering is what we are going to see. Now, what is that? We'll explore. I'm just going to put a small demarcation so that we'll know what happens after this. Let's leave the screen as is. It's not going to work. The expectation is we find a solution. The solution is going to be VPC network peering. Basically, you peer these two networks, get the routes, then the communication is going to be established. Okay. But if you try to communicate with external IP, it's going to work. It's going to work. At some point of time, we will slowly block the external IP address itself, folks, when we understand concepts more. Okay, for now I've just kept it for simplicity reason. Now the solution for this is VPC network peering. How do I do that? Simple. Go to your VPC. Yesterday from last week we are exploring VPC network, firewall rules, routes, shared VPC we have explored. There are a few more concepts which we are not explored. The other one which we are not explored so far is VPC network peering. So click on this. You should see an empty thing, and this VPC network peering you can also do it, folks. The only demo which you cannot do if you don't have a org account is basically your shared VPC. So VPC network peering you can also do it, so with your free trial. VPC cloud VPC network peering lets privately connect two VPC networks, which can reduce latency, cost, increase security, because it's going to be like two different GCP network. So because it's already GCP network, security is already taken into consideration. The communication is going to be on Google's backbone only. So latency is going to be reduced, cost is also going to be reduced. So a great advantage, and this is totally free. VPC peering has no cost. So only when you use the VMs and they communicate, then there's going to be a egress cost. It's not going to be too much. It's going to be lesser because you are not taking internet as a route. So egress cost has two things within GCP and internet if you are using it. So since you are using GCP network, it's going to be lesser. So let's create a connection, and this has to be explicit, folks. Both the sides you have to do the peering. But before you do the peering, right, I wanted to show you something on routes. For a minute, for a minute. I'm just going to delete the default VPC because it's going to little confuse us. I'm just going to delete it. We can create it. We have seen it. Time. Okay, the network is deleted. We have only two networks, and this is what we want to peer. So if I go to routes, refresh it. So you see these routes, folks. The routes related to all are basically are batch 6 and VPC Taiwan. Why 2 for VPC Taiwan? One is your internet gateway and the other one is your the local routes. So far this is the state. Now I'm just going to keep it like this. Go to another tab and create the peering so that you know there is a reference there, so you can come back and see what happened. So what I'll do is I'm in batch 6. If I go to my VPC network peering, I'm going to explicitly peer both these networks. So, and this is where one more thing which we are going to learn. So on the first day of the class, we understood GCP project ID should be globally unique in the GCP ecosystem, right? One of the reason was basically for VPC network peering to work. So when you want to do VPC network peering, right, you just need to have the project ID. That's it. So nothing else. It could be any GCP project. You can just, if you can get the access, basically you should have a compute network user role, a compute network admin role. If you have, you should be able to do it basically. So just needs a project ID and the VPC name. That's it, folks. The setup is very, very simple. So give a name. So I'll call it as peer 1 2 2. Or if this name is not good, we can do some, yeah, this should be good enough, I would say. So what's your own network? My own network is batch 6 custom VPC. And what is the peer network? Peer network, is it in the same project or in a different project? So if it is the same project, you just mention this thing. If it's in a different project, make sure you just mention the project ID, folks. And this is one of the main reasons why project ID is globally unique, at least in the Google ecosystem. So you don't need anything else basically. So first we will do within the project. So yes, the other network is also in the same project, and the other network name is called as VPC Taiwan. That's it. And there are a few options. If you want, you can leave it, or you can make it all unchecked. Basically, this is going to be an advanced thing which we are going to see later in our VPN. So there are going to be certain routes. If you want to import certain routes, you can turn on these things: import, export, custom routes. If you want, you can do it. So let's leave it as default for now. Unchecked everything. Uh, and this part was newly added. Public IPs was newly added. It was usually custom routes. Basically, what is custom routes? We'll come to that. We have not explored much about routes. What we know only is there's going to be a local route and a default internet gateway. That is what, and it's going to be auto generated is what we have seen. We have never created our own routes. So only when you create your own routes, static routes, dynamic routes, then you can appreciate this part. So that's the reason I'm going to leave it as default. So that's it. Gave a name, selected my my network and the other network, the peer network. That's it, folks. Create it. This is one side. So the same thing I have to do it from the other side also, from project 2 to batch 6. So let's wait for this to finish it off. Now once it has this, right, one side of the peering is done, it's going to show inactive. From the other side, you have to have it. basically is what it's saying. So I have done one side of peering. So now if I go to my routes, keep this as a copy, duplicate this just to see is there any change happened to my routes. So same set 1 to 6, previously also 6, no change. Now let me create the peer 2 to peer 1. Peer 2 to 1, where I'm going to use VPC Taiwan as my VPC, and the other one is going to be my batch 6. Simple. So click on create. The moment I click on create, right, I'm going to come back to my terminal, wait for a few minutes. Once the routes are created, the ping will start working, folks. The ping will start working. Let's wait for it to show up working. Now, two different GCP network. Currently, they are in the same project, but they are two different networks. Now we are able to communicate each other. The ping is working, and this entire communication is going to be using Google's backbone. Basically, I can show you that by doing a small demonstration also. But till here, is this concept clear? So if there are two different networks, GCP networks to be very specific, and you want to communicate each other using internal IP address, you can use it. Now you can use this as your org A, and you can use this one peer 2 as your org B. So if org A did not pay the money for that month, the subscription, simple, make sure you block that IP in your firewall. That's it, job done. So you have more control. It is decentralized, totally opposite to your shared VPC, which is centralized. Here it's decentralized. Each network, they have their own firewall rules, routes, all those things. So that's a key part here. Now if I go to my routes and refresh, you'll see some good amount of routes added. So you see some good amount of routes added, and if you lose track of it, simply look for routes which is starting with peering. That's one way. Or you can just click on peering. If you just click on this tab, it's going to only show filter out only peering routes. So you have auto generated, and these things cannot be deleted. The routes cannot be deleted because these are auto generated. So peer 1 to 2, what is this? Basically this is nothing but your, if you just do a small comparison between your network, so peer 1 to 2, the destination IP is that, sorry, 1 minute, peering. So from 1 to 2, 1 was our batch 6 to VPC Taiwan. So the destination IP from my batch 6 is to this one, which is my Taiwan. So the bridge is built. Similarly, if you do peer 2 to 1, so you have to have for all the 3 subnetworks. So because you have 3 subnetworks, so it's going to have destination IPs for that. Now the bridge is built now, and we are able to see it. The ping is working. Now to show that really it works on, it is actually communicating on Google network itself. What we are going to do is we are going to do enable a small API. Few of them are still in beta. So go to your network intelligence, network intelligence connectivity test is what we are going to show. Okay, but before I do that, any questions so far, folks, on the network VPC network peering?
Manish, is there any disadvantage to if you go with this option?
Decentralized, You want more control to your firewall tool. You don't want to always reach out to your centralized team to do it. When you want to have a software as a service offering, then decentralization, that is one thing. And it could be two different. Now you cannot have, basically it's two different organization itself, but you want to leverage this internal IP to reduce your cost, latency, all those things. VPC network peering comes automatically there. Those are the advantages. You have more control now. It's decentralized. It's more like a nuclear family. Hope that answers your question.
Yeah, I mean, but these are all advantages, right? Do you have any disadvantage if you go with this peering?
Disadvantage, the limits is one thing. So the number of stuff is one thing. Another disadvantage is it's non-transitive, right? Because of which I have to do every time explicit peering. There is an option
Okay.
which we are going to see called as Cloud VPN, mostly today end or next Saturday, where it is transitive in nature. Just because it is non-transitive, sometimes people avoid using VPC peering and use Cloud VPN. The biggest drawback is non-transitive nature.
Okay, thank you.
Yeah, and more limitations are available here. Uh, the detailed stuff is mentioned here. It's a nice document, but from the exam perspective, you don't need to go this much deep, basically. But if you are interested, you can definitely go to this link, the quotas of your VPC, peering, all those things. So now, any other questions, folks? Okay, I got it from Aman and Mangesh. It is clear. Now, what we'll do is, we saw this line, right? It's not just always marketing stuff. So the traffic really travels on GCP projects only. It never even hits outside network. To show you that, I'm going to leverage a service called as uh, network intelligence. Some of the features are in beta, but we'll definitely use it for our understanding. Okay, so the network intelligence API is not enabled. Let me enable it. What we are going to first do is we are going to see basically the communication between these two systems, server SG and server Taiwan, using external IP, folks, and see if it's external IP, the communication is going to take an internet route. Again, then later what we'll do, we'll have one more connectivity test where we are going to do a connectivity between these two things using internal IP. And it is going to be very clear the communication is not even hitting the internet. That's what it's going to happen. Okay, so let's just wait for the API to be enabled. Yes, the API is enabled. There are lots of options in network intelligence, network topology, performance dashboard, firewall insights. The one which we are going to leverage is connectivity test. This test analyzes your project to detect the configuration issue if it does not try to send packets through a data panel to verify. It does not try the package to the data panel to verify the connectivity. So only to check issues and all, it's going to be really helpful. So let me create a connectivity test. I'll call this as external IP. So these are the various protocols which you can use. I'm going to use ICMP. I'll get the IP address of server SG, paste it here. If you want, you can mention, is this IP used in this? If you want, you can mention it, yes. And what's your destination IP? So destination is my server Taiwan. Both are external IP, folks. Both are external IP. Now let me click on create. Ping is going to work. We know that. But the entire the way the packets are routed, that's what you want to see. So it says they are reachable using external IP address. The beauty of this one is you have to click on this result details, folks. That's where you will get a complete visualization how things happens. Click on this. You will really appreciate this UI. So first server is G. Then there's going to be a default egress outgoing traffic, right? The ping from server SG or pinging server Taiwan. So it's going to be an outgoing traffic. So your firewall rule comes into picture. Once your firewall rule comes into picture, basically, then a route comes into picture. You go out from your VM. So a route is needed. A default route is going to be used, which is going to basically take, if I just copy this one, go to my routes. What is this route, folks? It's taking internet to go out. Is this part clear, folks? Very important. So if you just see it from the VM, the firewall rule comes into picture. You are allowing, this is the implicit firewall rule. Look at the priority, it allows it. Then you need a route. Then the route is going to be basically the hop. The next hop is going to be 0.0.0. So which is basically your default internet gateway. After you do that, you're going to reach something called as NAT, network address translation. So where you're going to use the IPs, this IP, and there's going to be a specific, and the destination is going to be your server Taiwan. So more on NAT in our next class. So, but it is very clear the communication is going over internet. Once it does, it reaches server Taiwan. Then first thing which is going to be checked is basically the firewall rule, whether you're going to allow it or not. So because we have an ingress rule of priority 100 to allow incoming ping, packet is delivered. Packet is delivered. So a nice visualization. I was really very happy to see this visualization first time. It gives you a complete picture how a packet gets propagated. So is this part clear, folks? This is using external IP address. Now, and it is very clear it is using internet. Now, what we will do is we'll do the same test. We'll use the same test, but using internal IP address. Okay, and see what's going to happen. So internal IP, ping. Now I'm going to get the IP, which is this one. The moment I paste it right, it's going to show, looks like it's an RFC 1918 standard. Let me know what's the network. It asks that. So if I put this, you see this? The moment I put this, if I remove this, there's no info. But the moment I put this IP is from an RFC 1918 standard. Select the network. So the network to which it belongs is this one, because it is Singapore machine. So this is the network. Good. Then what's your destination? The destination is this one. The moment I put that, again it's going to show which network. So I'm going to say it as Taiwan. That's it. So what we did, gave a name, copied our IPs. Because it was smart enough to find its internal IP address, it asked us what's the network also. Now both these networks are already peered. So the moment I click on create, it's going to have the connectivity test done. Once it comes up, you will go and see the entire propagation of the packet. You will see no internet gateway is going to be there. It's reachable as expected, no wonder. Now if I see it, this is where the beautiful thing which you are going to explore. Server SG, from there same default egress firewall rule. Afterwards you get this one. This is the one which got created because of peering. So the next destination is going to be your VPC, peering VPC. Then your server Taiwan comes, your firewall rule, packet delivered. So nowhere it is using public internet. Nowhere it is using it. So is this part clear, folks? So it was only one liner, but I wanted to show you that using a small demonstration, the connectivity. This is really a cool one. And we are going to see this connectivity even in one more demo. So is this part clear, folks? It uses the same, it uses Google network basically when you are doing peering. So latency wise, it's going to be always very low because Google's network is petabit size. So petabit at rate, the bandwidth supported and the rate at which it can transfer the packets. Good. So if it's clear, the first part which we saw was between two VPCs in the same project. Now, what we will do is we'll do between two projects, and see it. So for that, I am going to just remove this. Now, tell me one thing, folks. Now, you have a default project. Now, let's just create one more demo and then proceed further. So, if I go to my, let me create a default project for a minute. Sorry, default VPC for a minute. Now, if you don't have any org policies set like skip default VPC, all those things, whenever you enable your compute engine API, default VPC is going to be created. You also have default VPC. I also have default VPC. Now, we are two different GCP projects. Now, if you were to peer with our default VPCs, what is the thing which you should do, folks? You also have default VPC. I also have default VPC. So how we are going to peer these two networks? Any thoughts? Any thoughts, folks? You can look into your default VPC. This is going to be something like this. My default VPC and your default VPC looks exactly the same thing. If both our IPs are going to be same, you cannot do it. Simple. You cannot even do this. So two different GCP projects using default VPCs. Both are going to use default VPC. You cannot peer it, folks, because IP conflict is going to come. So IP conflict is going to come. So this is another reason which you can think of why you should avoid default VPC. So if both the projects are going to use at least one project using default VPC, other project using custom, that's okay, it works. But both the projects using default VPC, you're going to have issues. So to make it very clear, right, in batch 6 I have default, and I'll go to project 2, and I'll show you that what's going to happen if between two projects you have VPCs which is having overlapping IPs. What's going to happen? Let's see that by doing a VPC network peering setup. So I'm in batch 6. I'm going to go to VPC network peering, create peering. So call this as batch 6 to project 2. The network is default. My project 2 VPC is totally in a different project. I'm going to select this one. Go to your other project. So project 2, you can get the project ID. from the URL, or you can click on this and copy it, your choice. This is the project ID, and the network which you want to peer is default. So I'm going to mention default only. Simple. Project ID, VPC. That's it. Nothing else. You need to be basically a network admin to get that. So I'm going to uncheck this, leave everything as default. Basically, this is usually unchecked, but I don't know why they have made this now. So let's click on create. The first time when you do, we know nothing is going to happen from the VPC side. It's going to be status is going to be inactive. You have to do the same thing in the other project. Only then the routes gets updated, right? Now I have done it in batch 6 to project 2. Let me do the same thing in project 2, where I do a VPC network peering. So there's nothing in project 2. Let me create the first one. So I'll call this as project 2 to batch 6. Select default. This thing is in another project. Let's get the project ID of our batch 6, which is this one. And the VPC name is default. That's it. Now when I click on create, right, it's going to throw me an error saying that there's an overlap, IP overlap. Let's wait for that error. I wanted to purposely show this so that you know whenever you are doing a VPC network peering between two different networks, IPs cannot overlap, basically. Let's wait. Yes. You see this? An IP in the peer network overlaps with the IP in the local network allocated by this thing. So what is the specific IP if you are interested? It's going to be some specific subnetwork. So if I just go, it is Europe West 6. Why you started it with Europe West 6, I don't have idea, but it's going to do peer one by one. So maybe it took Europe West 6 firstly, basically. If you try to delete this and do again, it's going to show one more. It's going to show you the same message 25 times if you try to do it. So basically two different GCP, and if they are having a overlap, they cannot be peered. Two default VPCs cannot be peered forever at any point of time because they are going to have the same thing. So this is another reason why you should avoid default VPC. So let's just add this part also in our cheat sheet. Why two default VPCs in two different project cannot be peered because of IP overlap. Is this part clear, folks? So you cannot do it. You are going to get an overlap of the stuff. Now I don't need this. So thank you, folks, for the confirming. So I don't need this. So I'm going to remove this. Appearing entry, which is of no use. Now what we'll do is we'll go back to the demo where we are going to do between two different projects, and we are going to use a network which is not going to have any conflict. So what I will do now is in this project also, anyway, I don't need this default. I just kept it for you to show that issue which will come if you use default, meaning if my project and your project, if you were to peer it, this overlap should be avoided. So what now we will do is we have VPC Singapore. I also don't need this. I'm going to delete this here also. So we have VPC Singapore, VPC Taiwan. Let's try to peer it, folks. Let's try to peer it. And by doing this, we can also show the VPC peering is non-transitive in nature. So I have totally batch 6 custom VPC. I have VPC Singapore, VPC Taiwan. These are the three VPCs which we have. So what we have done so far, and forget about in which project they are in. That does not matter. So these are peered. This is what has been done so far in our first demo. Now we are going to do one more demo where we are going to do something like this. We are going to do, and it's going to work. And these two VPCs are in two different projects. So that way you'll understand even between two projects, it's going to work. And what is not going to work if you don't do it, which we said non-transitive in nature. So your batch 6 custom VPC and Taiwan is not going to work. Will not work. The peering will not work because you have not explicitly done. This is what we wanted to see it, folks. So let's do that real quick. So batch 6, go to my peering, create a peer, batch 6 to project 2, select VPC Taiwan. Sorry, my bad. It is VPC Taiwan is in this project. What's not going to work is VPC. This is not going to work. We need to verify this. So which shows it is non-transitive in nature. This is what we are going to see it in this demonstration. So it's in another project. Get the project ID. And the VPC name, VPC Taiwan. Sorry, VPC Singapore. So I'm in batch 6. I'm creating a VPC peering between VPC Taiwan and VPC Singapore. This is going to get established. And we should be able to see the same thing. We should do the other thing in the other project also. Let me do it in my project 2. I'm in project 2. Let me create project 2 to batch 6. So the network is VPC Singapore. My other network is in another project, which is my batch 6. Batch 6. And the network name is VPC Taiwan. That's it. Click on create. IP overlap is not there, so it should get created basically. And the necessary auto-generated routes are going to be also created. Active. If I just refresh, this is going to be also active. So the peering has been established. Want to know the route details? You can go to routes. Click on peering. You should get the details. So if I just refresh it, you'll get those details. So you have VPC Taiwan, batch 6. Batch 6 stuffs. And if I go to my routes, I have my VPC Taiwan related stuffs. Now everything is fine. Now what we will do is we'll just do this check, folks. We know this works. We know this works because we created a VM. Using this. It worked. This works. Tested. Now what we are going to check now is VPC Taiwan and VPC Singapore. So since there is a VM already in Taiwan, I'm not going to create it. I'm going to create a VM in the other project, project 2. Call this as VPC, server project 2 SG, something like that. So create a VM, and in this project I don't have a template, so I have to do it myself. Let me quickly do that. So I'm going to call this as server project 2 hyphen SG Singapore, and this one, leave all other stuff default. Under my networking, I see my VPC Taiwan, sorry, VPC Singapore, my bad. Create it. Done. SSH. So do I have those servers? No. Let me just SSH into Taiwan, folks. Bad. 1 minute, folks. I'm trying to get back to back the screen. Okay, I have server project 2 SG and server Taiwan. If I copy the IP address and copy the IP address of server project SG, will it work now, folks? Before I ping it, is it going to work? Two different projects, two different networks, peered. Anything else? Firewall rules are already there. You don't need to worry about it. So don't even think of firewall rules. We have learned it, so I'm not going to again put that as a constraint for you to think whether that is going to be there or not. So will it going to work, folks? I got an answer from Anil Kumar. That's correct. Kumar got it correctly. Mangesh got it correctly. Let's verify it. Okay. It works. Vivek, what was the thought process which made you think it is not going to work? Curious to know what was that thought which made you think it's not going to work. Two different networks, they have peered. Should work. Firewall rule was there, so should work. Okay, no problem. Now this is good. This is good, and it's not a big deal. We understood it, so it worked. Now the key part to really understand the VPC network peering is non-transitive in nature. So what I will do is I will launch server SG and ping it and see whether it's going to work. Okay, so I'll connect to server SG. This is in a different network, batch 6. Batch 6 and VPC Singapore are not peered. They are not peered. We know that. Now let's see whether it's going to work. Okay, good. Both are in SG. So on my right hand side, I have Singapore server only. Left hand side also I have, so right and left, both sides have Singapore server. Now let's see whether they are going to work or not. So copy Not working. Not working. Copy. Not working. So this proves VPC network peering is non-transitive in nature. So you have to make sure it is always the IPs. Sorry, you peer the networks explicitly. So implicit peering, there's no concept of implicit peering. So is this part clear, folks? So all the slide components I wanted to show you by doing a demonstration. 25 networks I cannot do because for me it's only 5 is the one limit which I get as the VPCs which I can create. So with the limitations which I had with the free trial, I have shown you the stuff. So any questions on this part, folks? So non-transitive will not be tested in the exam per my understanding, but it's going to be heavily used in your real implementation. Any questions on this, folks, before we move to the next part? No questions? Good. So let's just do a small comparison. Now, I was expecting somebody will ask me this question. Can I use shared VPC with VPC network peering together? Khichdi kind of a stuff. So you try to mix two stuffs and try to bring out a new product out of it. So if you want to do something of that sort, yes, you can do that. There's a really a nice diagram in the Google website itself. It's available in the bookmarks. You can go look into it. Very, really nice diagram, which really makes your understanding well. So where I have a shared VPC, there's a host project. There's a host project, project 1. There are 2 service projects. Where is the service project? Yeah, service project. Where is project 2? Okay, 1 host project, service project 3, service project 4. Those are the one which is using the shared VPC. Yes, VPC is basically shared VPC. And there's one more project called as project 2 or P2, which is using network A. Now, basically network shared VPC and network A are peered, folks. They are peered. Now, since they are peered, VM2 can communicate with VM3. Similarly, VM2 can communicate with VM4. Can VM4 and VM3 communicate, folks? VM4 and VM3 can communicate? Couple of answers, which is wrong. 3 answers wrong. VM3 and VM4, can they communicate using internal IP address? Anil Kumar got it correctly. Aman got it correctly. It's going to work, folks. At the end, it's one network. It's one network, right? You are using a service project. This is service project. This is service project. So they are using the same network. I told firewall rule, ignore that for now because we have mastered it. Or not even master means at least we have come to an intermediate stage where we know how firewall rule works. So, or you could have said, assuming the firewall rule is opened, answer is S. So Anil Kumar and Aman gave it like that only. So basically, service project 3 and service project 4 is going to work because it's the same network. They are connected to the same network. Now VM3 and VM2 is going to work because it's already this network is peered. So the combination is going to work here. So any VM, if you think, it's going to work. But one bad practice in the diagram, which I would say, anybody wants to comment on any bad practice which is followed here? Forget about firewall rule. Any bad practice which is not recommended, but I've heard from this from one of the Googlers uh, Cloud on Air session. One bad practice here in this diagram. What is that? Which is not recommended actually. Having VM1 in project a host project. In host project, you should never create a resource except VPC, firewall rules, all those things, routes. Never ever provision any other resources. It is only dedicated for networking. Just keep it only for networking. So if you ask me, they should not have created VM1, but just to make the diagram simplistic and to explain the concept, they have created. Okay, so that's something about where you can see shared VPC and VPC peering used together. I was expecting you to ask this question, so you did not ask, so I thought let me share it myself. So one last slide, then we'll take a break, folks. A small comparison. So when it comes to shared VPC, it is centralized networking. We understood it. Everything you go change it in your one single firewall rule, or the in your shared host, host project. You do everything in your host project. For all networking related stuffs, go to your host project. But when it comes to VPC network peering, for example, if say for example server SG, I don't need this one. Okay, I have server Taiwan, ping it, works. Ping it, it works. Now all of a sudden there's some conflict between these two sub networks, something, whatever it is, political, business, whatever, some kind of a conflict between these two organizations, and they are not going to work together. Now what you can do simple is just go and turn off the firewall rule, not allow the IP. So maybe a server Taiwan, where in that project, if it's batch 6, in the batch 6, go control your firewall rule. So for example, what you will put is, if the source IP, this is a source IP, right? I'll put a firewall rule. If the source IP is this one, I should not be able to ping server Taiwan, is what I'm going to do. So let me just show you. And this is going to be in their specific firewall rules, not in a centralized firewall. So it's going to be their specific network's firewall rule. So if I just go to my firewall rules, VPC Taiwan, I'm going to say block non-payment So what I'm going to do is, it's on VPC Taiwan. So I'm going to make it as a little higher, or I can put it as that. That should be fine. 100 is okay. Deny all instances in this network. What's the source? If it is coming from this, basically, if I see the VPC, I'll definitely know the CIDR. Yeah, this is the one. So if I put that as I have put that, if I'm not wrong. Yeah, I have put it correctly. So block this till they do the payment. Deny all. That's it. Now this is only in my network I have blocked, because I'm decentralized. I have my control to my full this thing. So now if I go back, where previously every ping was working from both the sides, if I do this now, so Taiwan machine, if I try to ping it from, it's not going to work. It's not going to work because the project to SG, they did not do the payment. Now but from my Taiwan, they are little generous. They have not blocked it. The ping works. Now I have full control, folks, and it is decentralized. It's decentralized. So that's where VPC network peering really comes handy. The second important difference is this requires an org node. which indicates it's going to be bound to a specific organization. Whatever you do in shared VPC, it's within an organization. No two different organizations can use a same shared VPC concept. It has to be two different host projects, basically. Here, I only need two GCP network. Whether it's a free trial account, paid account, does not matter. It works basically. And an organization node is not at all a mandatory constraint here. Basically, in shared VPC, basically one VPC is good enough for me to do everything. That's what we saw. Here, minimum two VPCs is required. So a small analogy which I thought of giving is, it's going to be something like a joint family, a bigger family, one single network, all living in the same house. The house is going to be your VPC. So when it comes to your VPC network peering, it's going to be a nuclear family. So everybody in different houses. So individual, the different house is a VPC. Now, whether you want to communicate or not, basically depends on how the two different houses are connected, basically. So that's something on shared VPC and VPC network peering, folks. Okay. So we'll just stop it here. Take a 10 minutes break. Once we come back, this slide I'm going to upload it, Vivek. So this slide I added it yesterday. The reason why I have added adding new contents regularly is because new concepts needs to be updated, and exam content is going to be also made. A new content is going to be coming. New exam pattern is going to come, right? So let's be prepared. That was the whole reason I thought I'm revisiting my slides to make it more intuitive and make it more easier. So this was not there, so I'm going to upload it after the class. Okay, so we'll just stop it here. Let me stop the recording.
This conference will now be recorded.
So before the break, we saw VPC network peering, and we also made a little bit of a conclusion that what is the difference between a shared VPC and VPC network peering, when to use what, and a combination is also going to be possible. A question before we proceed further, folks. I have org A, I have org B. Within org A, there is a shared, there's a host project, org A, and within this org, there's a host project called as host org B. This is the project. So these are shared VPCs, because at the moment I say share host project, shared VPC is going to come into picture. So these are shared VPC. Now there are service project 1, service project 2. Similarly, here also you have service project 1, you have service project 2. Service project 3 and 4. This is the current setup. Now, if org A and org B are, for example, org B is acquired by org A, they come under one organization acquisition, and people who have gone through this acquisition stuff will know whenever any organization has been acquired, right, for the first 1 year, the organization which has been acquired, for in this case organization B, continues to work as an independent identity only. So on paper, on the taxation, all those things, it looks like one organization, but they still work as an independent organization. So I have gone through this entire stuff in my career. Whenever organizations were acquired, I have seen that. So this is reality. So even in GCP, you would have seen some products which was acquired. For example, Velostrata, then Stackdriver. They were having the names for a long time. Later, Google changed the names, basically. So that's what is going to be happening. So that's reality. So in the moment I acquire an organization today, tomorrow I cannot change all the branding, all the internal policies, all those things. So for a year, I need to understand how they work, all those things. So that's the reason people keep it like this. Now, that's the business angle of it. Now, when it comes to GCP part of it, now 2B is part of organization A. So meaning there could be some projects you want to interact each other using internal IP address. What will you do, folks? As a GCP cloud architect, what you are going to do basically, so that service project 1 and service project 1 here, they communicate using internal IP address. What is that you need to do basically? The question is, organization B is acquired by organization A. So there are different projects in both the organization. Now, previously there were two different entities. That's okay. Now they are part of one entity. Now I want to reduce the network cost, latency, all those things. So any projects which is there in host in this organization, both the organization, they should communicate using internal IP address. Internal IP address. Simple. I want RFC 1818 standard between two organizations, which was replicated. Beautiful, Anil Kumar. That's really a good one. Proceeding with that, what will you do? Assume that is there. What you mentioned, it is there. Vivek got it. What is it you are going to do that after what you mentioned? Yes, Mangesh, that's correct. Yes, Anil Kumar. So that's the thing. So Anil Kumar got it completely as really like an architect. Think like an architect, and he got it completely by looking at two steps. That was really good. Mangesh got it correctly. Vivek got it correctly. Anybody else wants to do it, folks? Simple. Very, very simple. So there are these networks, right? Peer it, folks. That's it. That's it. Job done. And the beauty with Anil Kumar mentioned was basically make sure there is no IP overlapping. Assuming in shared VPC, the host project org1, org-A and org-B, they don't have any overlapping IPs, I can go ahead with peering. If there's overlapping IPs, I should make sure either one of the network is changed. You change the network settings there, meaning basically create a new subnetwork, migrate all those things. Assuming there's no IP overlapping, VPC network peering is going to help you. So this is where you will see in real context where this is going to be used, So two different networks using shared VPC, but they want to peer it, just peer it. So, and now you will have n number of projects which can communicate over internal IP address. Just think like that, folks. That's going to make it more things. Some few things may not be even possible. We'll see some of the such questions where you will not be able to do that with VPC peering. I'll show that in a couple of minutes, or maybe next 30 minutes if I'm not wrong. Not every time VPC network peering is not the solution. Only if it is a GCP network and you have access to both the network, to both the projects, you can do that basically. Now, if you see, the emphasis is more getting towards private IPs. Private, everything is becoming private, right? So what are the various other options which you get? And so far what we have done is always very simple. Two VMs, whether it is in the same VPC, different VPC, or in different project, you just ping it. Not always in GCP or in cloud, it's not always virtual machines, right? There are other resources, storage buckets, Google Cloud Google Cloud SQL instance, n number of resources which we have also seen. So how is the communication going to be established with the other services? That is also something which you need to explore. It's not always two VMs just do ping. So that is what we are going to see in the next few slides. Private access options for various services. There are two types of services which you get private access options. This is little confusing. So again, I got this tree diagram from one of the Google Next videos, 2019 videos. Cool video. I forgot to bookmark that. But if you search it, you should be able to get it. If you don't get it, let me know. I'll try to search it and get it. It should be in my history. So basically, there are two types of private access. First of all, if it is built on Google infrastructure, then you get something called as private Google access, where you can access from a virtual machine a YouTube API, a Google Map API, a Google Cloud Storage API, a BigQuery, which we have not even seen yet. So anything on Google infrastructure, if it's running, I can use private Google access. So from a VM, I can easily access it. On the other side, if it is on Google Cloud Platform, now you may ask, is Google Cloud infrastructure and Google Cloud Platform going to be different? In my sense, it's going to be, I would say it's like the components, all those things are going to be the same, but where they have deployed is going to be different. For example, to just make it very, very simple, at least based on my understanding. So if I just go to Google data center, so Google's data center location. Most of them are ads. Okay. So if I look into the location, right, these are the locations which we have, folks. At least for Asia, it's in Taiwan and Singapore. This is where the actual Google services like YouTube, Gmail, Google search engine, all those things are served. So if you're in India and if you're accessing YouTube, basically it has been served from Singapore data center. Okay, this is Google infrastructure. For the end user products, this is the infra. Similarly, there is specifically Google data centers, the zones which we call, they have been created in 25 regions. So that's going to be a Google Cloud Platform infra. So there's going to be a difference, but the components used, maybe the networking component, all those things are going to be same. Okay, so if you were to access some Google Cloud Platform resources, especially which is provisioned only on Google Cloud Platform, like Google Cloud Storage, Google Cloud SQL instance, memory store, then you will use a service called as private service access. So if it's Google resources, YouTube, Gmail, Google Maps, or some other products in GCP itself, you have few things like Google Cloud Storage and all, you can easily access using private Google access. If you have to access specifically products like, and there are only 4 products under private service access, which is Google Cloud Storage, Memory Store, Cloud Build, and there is one more thing which is private GKE master or something. So very limited options only. So if you want that, you are going to use private service access. To be very frank, we have already discussed private service access when we did our Cloud SQL demonstration. When we enabled private IP address, right, it actually enabled this behind the scene. So it behind the scene. So why this is now coming into picture is because when you are using private service access, it's going to use behind the scene managed VPC network peering. So what you learned is already been used by Google for their internal working itself. So that's where it's going to be used. And when you are going to access private Google access, basically the resources like Google Cloud Storage, BigQuery, Spanner, YouTube, any Google APIs, you are going to use a proxy. So connection is via secured proxy to the Google's infrastructure, which is, and the traffic is going to be routed on Google's backbone. A complete details is available in this link, and I'll try to explain you in a simple term what is private Google access and what is private service access by doing 2 demonstrations. Okay, so the first thing which we are going to see is private Google access, because to some extent we have already seen private service access. So first we'll start with private Google access. What is that? So from a virtual machine to some other GCP resource, except Cloud SQL instance, memory store, and couple of more stuffs basically. So private Google access. So if you were to do access a virtual machine, maybe there is a storage bucket. From a storage bucket, you want to access a data from your virtual machine. So if that is the case, usually what will you do? You create a storage bucket, upload some objects, then you create a virtual machine, go do gsutil and get the details. This is what you used to do all these days. Now the hidden truth is, behind the scene, the communication between a virtual machine and a Google Cloud Storage, both in the same project, was still using external IP address. Can you believe it? So all these days, whenever we were accessing a Google Cloud Storage bucket, it was taking an external route. It was using internet to access it. That's by default is what you see, and that is what you will see it in your default VPC also. So and another reason why you see default VPC should be avoided. So this is something it always going to take an external route. Now today we will see how we can use without an external IP address. How can I access it? Is what I wanted to show. So now it's between not VM to VM, it's VM and Google Cloud Storage, two different resources, but the communication is going to be using internal IP address. So let's see how it works. So for this, I'm going to use my batch 6 project. Go create, let me see whether I have a bucket. I should have a bucket. Okay, I have a bucket and I have some couple of objects. Okay, now I'll go create a virtual machine, folks. Simple. And I have removed all the VPC peering, blah, blah, blah during the break time. So it's, if you see back in batch 6, it's going to be simple 2 networks, firewall rules, 2 firewall rules, no VPC peering, everything. I have made it as a clean slate back. Now what I'm going to do here is, as shown in the diagram, I have a storage bucket and I'll use a virtual machine to connect it. First we will use with all the default setting, then we'll see internal IP option. So I'm going to use the template. If I can see my V project where it is created, sorry, storage bucket where it is created. It is in Singapore. As a best practice, because there's some data which I wanted to access, keeping the processing unit, which is your virtual machine, in the same region where is your data, it's going to be a good choice. Because my data is in Singapore, I'm going to create a virtual machine in Singapore itself, so that I can reduce my egress cost and to a great extent. So same region is going to be better for data processing. I'm going to call it as server data processing SG. So sorry, I should have used the template. Server data processing SG. I will use either one of the network, should be okay. Either one of the network should be okay. Batch 6 also has a subnetwork in Singapore. Okay, Taiwan does not have. I cannot use that. Okay, batch 6 should be good enough. And I'm going to leave everything default, folks. I just given a name and I've selected the region, zone and the region. That's it. Everything is default. Now let me go, and I'm also using basically default service account. Where is that? Default service account. So meaning it's going to have basically read access to my storage buckets. Standard. Done. All default. And this is what we were doing from the first day when we are interacting with our virtual machines. Create a virtual machine with all the default settings. Try to connect to your Google Cloud Storage bucket using gsutil command, and it was working. And that is what it's going to also work now also. Just wanted to repeat it, what we were doing all these days. Done. It has an internal IP, it has an external IP, and it is in this project. And the service account is a default service account. So which is going to have basically read access to the storage bucket. So you can see that this is my default service account, and you are going to have read only access to the buckets, all the buckets. Let me now SSH. All good. Let me do gcloud auth list just to indicate I'm using that compute engine default service account. Good. Now if I do gsutil ls, it's going to show me the bucket, what is there. When I use it's going to show me the stuffs. So far so good. Standard one, no rocket science. This is what we have been doing from the beginning. So now I'm going to do a simple change, folks. Just close this. Only one change, because we are talking about networking. I'm going to remove the external IP address, nothing else. All exact same changes, same things, only external IP address I'm going to remove it. So click on edit, go to my network. You see the external IP address, which is ephemeral, which is going to change the IP when you stop and start it, or 24 hours it's going to change. So if I just do this, more on reserving the IPs, we'll talk about it in today's class itself. So I'm going to change it as none. I don't want an external IP address. A great step towards more secure system. So done. No external IP address. So let's just wait for a minute for this change to happen. Nothing else I have done. Only remove the external IP address. So service account is the same. Everything is the same. Only external IP address is removed. Let's wait for the changes to reflect, folks. It's just saving it. Saving. Yeah, it's saved. Now if I go back to my main screen in this thing and refresh this, this external IP should be gone. So let me just refresh it. Not there. Refresh it one more time. It's there. It's not there. It's none. So the changes are reflecting, and just to show you, the service account is the same. And all these changes which we did was when the VM was running only. So I can add, allocate an external IP address, remove an external IP address on the fly without any downtime. So storage is read-only access, and it's a default service account. Now let me SSH into this VM. And let's see what is going to happen. I'm there. Same command just to show you everything is in place. Same service account. Now let me do gsutil ls. It's not going to work. It's not going to work, and it gives it very clear. It was using storage.googleapis.com, so which is an external IP. So basically it was using that to connect. Now if you remember, yesterday we had seen, to have a internet connectivity, what are the three points which you should have, folks? For a VM to have access to internet, you should have basically, if I just go back to this thing, internet firewall. So you should basically have an external IP address. It should have a egress firewall rule. It should have a default route, internet gateway route. Only then it's going to work is what we had seen. So firewall, internet access. Yeah, this is the stuff which you see basically. The following must be satisfied for an instance to have an outgoing internet access. So one is the gateway. We have not even changed it. It's going to be there. Firewall rule, we have not changed it. So good. One of the condition must be met. Either you have an external IP address or a NAT. We don't know what is NAT at this stage, so let's ignore it. We know what is an external IP address and we have disabled it. And that is the reason why you are not able to even do gsutil ls, folks. So even for your gsutil ls, it's not working. So basically it was using behind the scene. Okay, I have to increase my font. 1 minute. Basically, I was using the stuff which was using behind the scene was storage dot googleapis.com. This was the one which was used behind the scene. So for which you need to have an internet connectivity, which is not there because you have ns lookup. If I do it, it has a good amount of presence. Good. So this is what it was using behind the scene. Now it is not able to connect itself. Now it's doing a retry. It's doing a retry. And just for your information, gsutil is written in Python. gsutil is written in Python. So it has a logic of doing a retry if something is not working. So it tries. It keeps trying and it's not going to succeed. It's not going to succeed. It is very clear a connectivity is not happening. Now I'm just going to do Control C, come out of it. Now what is the solution for this is basically private Google access. How do I enable it? Very, very simple, and it is totally free. Just go to your, what is the network in which it is there, and what is the sub network which is this there. So just go and enable it. That's it. So go to your network. So this is the network which you have network, and the VM was provisioned in subnet Singapore. So when you click on subnet Singapore, you get an option called as private Google access. If I just enable this, which is by default off for any subnetwork, it's going to have the communication established. So let's try to do it back to back like this. Okay, so I'll do, it's not going to work. Now what I'll do is I'll click on edit only that specific subnetwork where my VM is running. So instead of off, which is the default option, I'm going to click on. Click save. The moment I click save, I should see the response here. That's it. You see that it is now able to work. The reason why you saw this bash was because I had put star. Now my stuff is working, folks. I don't need an external IP address anymore. Everything is going to be routed on Google's backbone. Beautiful option, right? And it's totally free, and I don't personally feel any drawback of having private Google access enabled. I did not find any this thing till now. It works like a charm. Now you can use this for various purpose, folks. Just take a scenario, something like this. A scenario like this where VM is not having an external IP address like the one which you have, now. If I just go to my VM, so VM with no external IP address. If it does not have external IP address, what's going to happen? Basically, if it does not have external IP address, I cannot do ping. Basic networking stuff, it's not going to work. If I cannot ping, then how will I install softwares? If I want to do some patch updates, the operating system is what? It's a Debian operating system. If there's any patch updates or some software which I want to install, I usually do sudo apt update. If I do this, it is also not going to work. So no access to internet is going to be a problem. Now, if my organization policy says any VM which you create will not have external IP address, then one option which you can leverage with the demo which we saw is somehow get an offline version of the updates, the packages, put it in a Google Cloud Storage bucket, enable private Google access, then you can easily access with internal IP address itself. Simple. NAT is another option which we'll talk about that into next class. One simple option, maybe it can take little time, so you to get a get an offline version of it. Basically, I used to do this when I was in my college days. So I had a laptop which was not having internet connection, but I used to use my floppy disk very often, so virus used to come. So I had a antivirus which was free. So but this antivirus was getting off like was getting I need to update it very frequently. So I used to go to an internet browsing center, download this thing offline version and do it. So I used to do that. So something similar you can also do if you want, where you don't have the VM and external access, internet access, but you can access a GSUtil bucket. Access the GSUtil bucket, download it and update your operating system. So totally zero cost for having this enabled. So only thing is that you are going to upload the data to Google Cloud Storage. Uploading is going to only cost your internet cost there. That's it. So this is one easy option of exploring it. Something on the similar lines, I had got a question when I was taking my first certification. So something like, there is a secure system, you cannot have an external IP address, but you need to update a patch or you want to download a software. How do you do it? The simplest option was enable private Google access at a subnetwork level. This is very, very important. At a subnetwork level, you enable it where the VM is running. Then you can access the stuff from your Google Cloud Storage and do it. Simple. But this is at a subnetwork level, folks. Private Google access is at a subnetwork level. If I just go here and create one more time a VPC, create a VPC, demo VPC. I create a subnetwork. I'll add it. I'll just add it. Subnet demo. Select region as Mumbai 172.30.1.0/30.24. Now you see this, folks. Remember, I used to leave everything as default. I used to only do the custom subnetwork, and I used to leave this. I told we will not do that now. So now time has come. So we are exploring private Google access. And if you just mouse over, right, most of the stuffs, if you spend some time on the console itself, exploring those tooltips, concept becomes very clear. So they have designed the UI very nicely. So set whether the VM in the subnetwork can access Google services without assigning an external IP address. Simple, right? One line statement makes it so clear. So by default, it is turned off. So you have to turn it on. You have to turn it on at each subnetwork level. Each subnetwork. So this is subnetwork. So now if I have another subnetwork, I have to turn it on. So this is at the subnetwork level. So let me just add this in the cheat sheet. So private Google access. So this is at a subnetwork level, which is regional. So route, it is global. Okay, so this is very important. Private Google access. With just a small radio button, you can turn it off and turn it on if you want. Basically, that's a cool thing. And each and every buttons are going to be really helpful, or options are going to be helpful. Now, so far we have not explored flow logs. We have not explored dynamic routing mode. We'll explore it as time comes. So only when a need arises, when you explore it, right, it's going to be very intuitive. Instead of me saying all the features in one shot, you'll not get it basically. So that's on your private Google access. Similarly, you can use the entire other services like BigQuery, lots of other services, YouTube APIs, everything can be accessed via internal IP address itself, basically. So that's the first option. The second option is private service access. That is Google access. This is service access. So here, this is going to be primarily on anything which you want to access, basically, which is provisioned in Google Cloud Platform infra. Then you are going to use it, and it could be even third parties. NetApp could be another possible option, a third party which you can use it here, where you can communicate between your NetApp and virtual machine using internal IP address. Third parties and some few Google services like or GCP services like Cloud SQL instance, memory store. They all use private service access. And to be very frank, uh, we already used this demo, but without our awareness, we used it. Now we have a good understanding on networking. Let's go one time create a Cloud SQL instance with private IP address, only with private IP address, and see how it works. Okay, so for this, I wanted to show you some stage. What is the current stage? What is going to happen? For demonstration purpose, I'm going to delete the batch 6 VPC, folks. Should we delete it? Let's keep it. Let's keep it. So let me click on batch 6 VPC. You'll get the details, the subnetwork. Is there any internal IP? We have not come to that. Static internal IP. Firewall policy, which is a new feature which we have not explored. This is at an org level. Firewall rules we have explored. Routes, we know what exists. Then VPC network peering. If you have any peering there, it's going to show it. We explored that. The last option which we have not explored is private service connection. This is the one which is going to be used for your private service. So when you create basically a Cloud SQL instance with private IP address, a memory store instance is going to always have a private service enabled. basically how it works, let me show you. Currently, if you see, there's nothing. What I'm going to do now is basically, and there is no peering also. There's no peering. There is no entry in your private service connection. When I go enable a Cloud SQL instance, when I go create a Cloud SQL instance, in any of the region subnetworks which we see with only private IP, you will see basically a private connection enabled and also a peering enabled. Peering also is going to be enabled. This is going to be a managed VPC network peering, which is going to happen. So let me just quickly create one. So call this as learn VPC peering private service access demo. So I'm going to keep a simple password and I am not even going to log in. Demo GCP. So I'm going to use the latest version. I'll put it in Singapore. Single zone is enough for me for this demonstration. The most important thing in this context is basically the where's that? Let me first make the machine type as small as possible. Wow, a core is good enough. The most important in this demonstration, because we have gone through the entire stuff once, so the most important thing is the IP. Where is that IP? Connection. This is the most important stuff in this context, folks, in our Cloud SQL instance. So I'm not going to use public IP. I'm slowly going to avoid external IPs going forward now. So I'm going to have only internal IP or private IP. Requires additional APIs and permissions which may require your system admin cannot disable once enabled. We have seen it. Once you have a private IP, you cannot disable it. Now I select my private IP. Now I see two subnetworks, sorry, two VPCs, batch 6 and VPC Taiwan. I'm going to use batch 6. Now it says private connection, private service connection required. Your batch 6 requires a private connection. This connection enables your service to communicate exclusively by using an internal IP address. Between my Cloud SQL instance and my virtual machine, I can have a private connectivity, so I can use internal IP address. So when I click on set up this connection, what's going to happen behind the scene is there's going to be a VPC peering created and a private connection is going to be allocated. A specific IP range is going to be allocated. And then based on that, your Cloud SQL instance is going to get an IP address. So let's click on setup connection. So you see private service connection as per the VPC network and can as are per network VPC network and can be used across managed services like memory store, TensorFlow, which is not going to be something which we are going to discuss. That's for data engineers and machine learning engineers. SQL. So these are the products which is going to be heavily used. You are between your VPC network and a network owned by Google using VPC peering, enabling your instance and services to communicate exclusively using the internal. So please remember, it is between your network. What is the network which you choose? Batch 6 custom VPC and a network which is owned by Google. Owned by Google. You will not have access. It's a peering between your network and Google network. Create an isolated project for you. Create an isolated project for you on your service producer side, meaning no other customers share it. You will be built only for the resource you provision. So basically, and literally, what is going to happen is when you create a Cloud SQL instance with private IP address, a Cloud SQL instance gets provisioned in a different network altogether. That is Google own network, and that network and your own network, the VPC, is going to be peered, and that is the reason why your VM can communicate with your Cloud SQL instance. Let's see that. So this API is already enabled in our Cloud SQL demo itself. We had enabled it, so not required anymore. Once enabled already. Allocate an IP. So this is the IP which is going to be used by your Cloud SQL instance. So if you want, you can give a range, or you can just leave it as automatically allocate. When it is going to allocate, it's going to be basically an RFC 19187, because we are talking all about internal IP. Click on automatically allocated. Now click on create. Once it gets completely enabled, what's going to happen behind the scene is a VPC network is going to be used, peering is going to be established, and certain IP address is going to be allocated. It's going to take little time, so let's just wait for it to come up. If you want, we can just go and see, refresh it and see what's happening. You see something came, something in peering it came. I'll explain the details. So there is an IP allocated. So I'm 300% sure. Now, when the Cloud SQL instance with the internal IP address gets provisioned, the IP of that Cloud SQL instance is going to be 10.255.64. something. The first 24-bit, I can easily say what is going to be the IP, because this is the allocated IP. And you can also see some private connections getting enabled. So we have to wait, and that's the reason it is taking time. Okay, it is enabled now. If I just refresh it one more time in my network, I'll get a complete picture. Peering, there is one thing, and it is called as, if I just go to my, okay, let me see this here. So allocated IP, then private connection is this one. Then under peering, if you see, there is something called as service networking APIs.com. Now, if you just go to your VPC network peering, let me remove these columns. Okay, take a minute and let me know what do you feel from this entry, folks. Just take a minute and see what does you get from this entry. It's a VPC network peering entry. What and all do you get from here? Okay, by the moment you okay, I would have, let me click on create first, then you can start thinking. So the private AI API is enabled, so I'm just going to leave everything as default, because this is not a Cloud SQL demo. So this is on private IP address stuff. So I'm just going to leave everything default, only private IP has been enabled. So click on create. Anyway, it's going to take 7 minutes. Now you can start thinking, what is this basically? By just looking at this entry, what do you get, folks? It is using Google APIs, and it is using private API peering with Google API subnet. Okay, good. And peering, is it going to be with subnetwork level or VPC level? Peering is at a VPC level, right? Yeah, it is going to be at a VPC level. Good. Anything else which you get, folks? There's something very important which is revealed by Google here. Anything else which you get? Different project ID. Good. That's important. That's good, Mangesh. Their project ID. So basically what you get from here is, this is your own network. This is your own network. This is the other network which Google has. Their Google owned network, and the project ID of that network is something ending with .tp. TP stands for tenant project. TP stands for tenant project. So basically, this is Google owned projects, and you'll be billed based on your usage. Basically, that is what they mentioned. So this is one peering entry which you see. This is between your own network and the network which Google owns. So that's an important thing. So this is their tenant project. Okay. Let me just see whether it is done. It is going to take a minute, more than a minute if I'm not wrong. So let's wait for this to come up. By the time if it comes up, if I refresh it, I should see a few more entries. You see one more entry, folks. This is Cloud SQL MySQL APIs, Google APIs.com. There's one more entry which is coming up. One more entry which came up. What is this all about now? Same thing. Between your network and there's one more network which Google owns. And usually for everybody, it's going to be the same ID. Speckle-umbrella 56 or something. So it's going to be usually speckle-umbrella some number. You can also go try it. It's going to be the same thing. So another peering entry added. Let's see whether the Cloud SQL instance is up. Not yet. So basically what's going to happen is, between your own VPC and a network which Google created, basically my Cloud SQL instance which is getting provisioned, it is created here. It is created here. Now you may ask me a question, why can't Google create it in the same project, in the same VPC? I don't know the technicalities why they are doing that. To be very frank, the Cloud SQL instance with internal IP address was not available for a long time. I myself have asked a few Googlers whenever I went to go any events. So the answer was, it's coming, it's coming. So after a long time, it came up, but I don't know why they have used this feature. Basically, even I have to do some more exploration on this part. But whenever you use a Cloud SQL instance with internal IP address, it gets provisioned in a different VPC, which you will not have even access to, basically. But you'll be billed basically there. So let's wait here. If I refresh it, do I see any more further entries? And the IP, public IP will be empty. Internal IP address would be definitely 10.255. That was the one which was allocated. It should be the same thing. So if I just go to my VPC, click on the VPC, it's going to be something like this. That's the allocated IP. So let's wait for the VM. Or why don't we take a 10 minutes break, folks? So it's going to take time, looks like. So let's wait. Let's take a 10 minutes break. Come back. By the time we come back, the instance should be ready. We can then try exploring more on this. Okay. So let me stop the recording.
This conference will now be recorded.
So before the break, we tried to provision the Cloud SQL instance. Let's see. Yes, it is provisioned. And as mentioned, the IP address is exactly matching with what we saw as the allocated IP, 10.255.64. That is what it indicates, and it does not have an external IP address. Now all good. Now what I will do is, I'll try to show how we can connect this virtual machine, this VM Cloud SQL instance with our virtual machine. So let me just show you that. The VM is also going to have internal IP only. Now, this is in this network, and this network, which is where our Cloud SQL instance is provisioned, are peered. Meaning I can communicate with this Cloud SQL instance, which is this IP, using internal IP address. I can even connect to it basically. So let me SSH first of all, refresh it, SSH. I'm there. Now, because it's a MySQL instance, I should basically have a MySQL client basically. So if I type MySQL client, I don't have a command. So this utility is not there. So I have to make sure this is there. This utility is there. So uh, basically I have to do something like sudo apt update, or install Maria. This is the same thing which we did, MariaDB hyphen client. You have to do something like this. But now when I try it, what's going to happen, folks? In this virtual machine, if I try this with the same command in the virtual machine, what's going to happen? What's going to happen, folks? It will not work because it does not have an external IP. Want to verify it? Oh, is it going to work? Let me see it if it works. So there's going to be some internal cache somewhere. Let me see whether it works. No, it does not work. As Anil Kumar mentioned, it does not work. We also get it clearly from here. So it's not able to connect to internet because it does not have an external IP address. Now we have to get this client for it to work. So maybe one option is have the external IP address enabled for a short time, then install it and remove it. That is one way, which is not really a good practice. The better way is what we have learned already. So it got that error. It's not fixed. So it's having issues. So if I just do MySQL, it's not going to be there. So it's not going to connect because of no external IP address. One option, as I mentioned, short time enable it, which is not really a good practice, and assume if my org policy has done something like no VMs should have external IP address, then I cannot even do that. So then there are two more options which is left. Is one, you somehow upload MySQL client in a Google Cloud Storage bucket. I can get it with my private Google Access option. That's one option, but I have to get the installer somehow. The third option is using something called as Cloud NAT, which we have not talked. We are going to talk about that in our next class. So let's see our private Google Access itself coming in action to access it. So I don't have the client, but if I do a small trick, what I'm going to do is I'm going to launch my Cloud Shell, and I'm pretty sure Cloud Shell has a executable or this installer. If I just do MySQL, there is a version there, and if I see my OS, it is Debian 10, and my Linux machine which I have provisioned, it is also Debian 10. I'm not sure whether it's going to work, folks. Just a trying part. So if I type which MySQL, I'll come to know the location of this. So this is the location. I am going to do something like this. What I'm going to do is copy this MySQL.e executable. Not sure whether if I do a copy, it's going to work. I'm just giving a try. So not so comfortable with the Linux, whether it's going to work or not, but let's give a try. So I'm going to use, basically, I'm in my current working directory. So I'm just going to do a copy or sudo copy dot, meaning I have a MySQL executable in my home directory, Now what I'm going to do is I'm going to use gsutil ls, copy this executable to the bucket, gsutil cp MySQL to this bucket. Just giving a try, folks. That's it. Okay, now it is there. If I go to my virtual machine, because of private Google access, I should be able to see a list. I should see that MySQL is also copied. Now let me just copy it and see whether it's going to work for me. gsutil cp to my current working directory in my virtual machine. So if I put ls, I see that, but it's not an executable. Let me make it as an executable by doing change mode. Done. It's now executable. Now let me see whether it really works. Okay, some dependencies are there, so I have to copy it. Maybe if I copy it, it may work. So that's the reason I told. So there are going to be some dependencies, or we have to get some offload version, like download an offline version of MySQL client, put it into Google Cloud Storage, then it should work basically. But if you want to give a try, I can just give a try. It's a very crude way what I'm doing, getting the executable somewhere or locate. I'm not sure whether it's going to work. Okay, no worries. If I can get Maria DB client zip Debian downloads. I did just need a client. That's it. Let me just go download data. It's a server basically. I have to download it, upload it, or maybe for a short time I'll just enable external IP address, folks. This is not something which a cloud architect is going to do. So I'm just going to enable an external IP address quickly. I thought it's going to work. Maybe I can give a try later, so I don't want to waste your time. Me doing a research on how to install it. For a short time, I'm going to enable it. In next class, we will see Cloud NAT is going to be a better choice. We'll see that part. Okay, it is now created. Or if I now refresh it, I should have an external IP address. If it's having external IP address, all good. I should be able to install the module, and I'll make it very clear. Only for installing the module, I'll use the external IP address. Afterwards, I will not use it. Okay. So first, I'll make sure I remove this. So let me install the client. Because I have internet connectivity, I'm able to do that.
So if your configuration of your machine is little small, it's going to take time to install it. This is what I have seen basically. So ours was F1 micro, if I'm not wrong. It's going to take time for it to install. It's going to take time for it to install. By the time this comes up, right, I'm just going to create one more virtual machine in a different VPC. Instead of just waiting for that, I just wanted to create one more virtual machine. I'm going to give it little powerful component, server hyphen what are the London. Let me make it as London. Let's give little powerful capacity so that we can quickly install the component. Go to networking. I'm going to use batch 6 and it has a presence in London. So external IP required only for installation of that thing. Let that VM get created. I'll create one more instance, but this time I'll create it in London itself. I cannot create. I'll create it in Taiwan. Server hyphen Taiwan. Give more some capacity for installing it, because if you see, it is still installing. F1 micro is still installing. It's going to take time basically. But this time I'm not going to use batch 6. I'm not going to use batch 6. I'm going to use VPC Taiwan. VPC Taiwan. That's the difference. Still installing, folks. You see true value of a capacity, a compute. If it's really good, you will see how quickly it does. If it's so slow, we finished creating 2 virtual machines, still in the installation is not finished. Maybe I'll just SS it into the London machine, which is in the same VPC. Try to basically install it. Maybe I can finish it is what I feel. So F1 micro will have that issue. Only for learning purpose you can use it. So I'm accessing into London machine. I'll do sudo apt update. Same thing, I'll do it in Taiwan also. London done. Sudo apt install Maria tb hyphen client. Let me do the same thing in this thing. Both one after the other. So I have it already in my London, and let's see whether it is done. So in our F1 micro machine, it is still installing, folks. Real case where you see the power of a vCPU and memory is very important. You see it by yourself. So London, Taiwan, all good. So let me just go back to my Cloud SQL instance. Go to London, first London. Now let me get the IP. I'm in London machine, MySQL -h -u -p. demo user GCP. I'm there. I'm connected to my from my London machine. I'm connecting to my Cloud SQL instance, which is provisioned in Singapore using internal IP address. So straightforward option. Same is the one which is going to happen for this Singapore machine, but it is taking still longer time. I'm not sure how long, but I can just close this. It's going to take longer time. Now, a question for you people. If I do the same thing for Taiwan machine, what's going to happen? What's going to happen, folks? If I do with my Taiwan machine, so MySQL is there. Will it work or not work from my Taiwan machine, which is in a different VPC? Your Cloud SQL instance is in another VPC. Is it going to work or not work, folks? Any thoughts? Why it will not work? If it is, why it's not? Why it's going to work? Both reasons. Not work. Yes, because they appeared. Okay, let me hit enter. It's not going to work as Anil Kumar and Vivek mentioned. And the answer from Anil Kumar is correct. Basically, if you see the stuff, folks, look at your peering requirement. Now let's make it very, very crystal clear here. I have VPC Taiwan. Okay, I did a mistake also. VPC Taiwan. I have batch 6 custom VPC. These are the VPCs which I have. VPCs. And there is one more thing which is created by Google. This is also one VPC. This is also one more VPC, which we did not create, but Google created it. So there are totally 3 VPCs which we have. Now, peering exists only between this and your only between these two it exists. Now, there's no peering which exists between your VPC Taiwan. So maybe that's the reason why it is not working. Now let's try to peer VPC Taiwan and server batch 6 custom VPC and see whether it's going to make any difference. Batch 6 to VPC Taiwan. Batch 6, it's here only. Done. One more time. VPC Taiwan to batch 6 custom. VPC Taiwan. That's it. The peering will be created now. The peering is now between. I have created the peering between it's there. Now can I do, folks? Will it work? Now the peering is done. Can I connect? Will it work? Looking at the current setup, will it work or not work? How about now, folks? The screen answer is on the screen. Beautiful, Anil Kumar. Yes, Mangesh. So it's not going to still work. The reason is because of VPC network peering is non-transitive in nature. So what you have peered is batch 6 is a common VPC between both. But for it to work, you should do basically this network should be peered with this network. Only if you can do this, it's going to work. Otherwise, it's not going to work. Let's verify it by just connecting it. Demo GCP. It does not work. So just because you have not done the peering between that a network which is provided by Google and your own VPC, the peering will not work basically. Now, if you say, can I do it? You cannot do it. Why? Because you don't have access to this. What is this? Uh, Speckle Umbrella 56. You'll not have the access to this project because in that project also you have to do the peering, right? Only then with your VPC Taiwan it's going to work. So basically, this is a standard question people ask. I had seen many people message me in LinkedIn for asking this. So it is something like this. I have VPC 1, I have VPC 2, provisioned a VM, Cloud SQL instance, Cloud SQL here. I have a VM in this one, VM. Can VM access Cloud SQL instance using private IP? Answer is no. The reason is they are in two different VPC. Even if you do peering between VPC 1 and VPC 2, it's not going to work. So VPC 1, VPC 1, you may peer it with VPC 2, and VPC 1 actually is peered with a network, something which is going to look like something like this, which is because of that private access, because it's a managed service they create it for you automatically. But VPC 2 will not be able to peer it with your Cloud SQL instance. So because of which this is not possible. So this is not possible. Now, straight away, this is not possible. But there are workarounds which I can share with you. One possible workaround, a very basic way of doing it. But I have done in the past one slightly different approach. I don't have the configuration with me, but I had done some changes with respect to the routing table, was able to do something there. So, but is this part clear, folks? The non-transitive nature, you should keep it in mind always. Is this part clear, first of all, before I proceed to give you the workaround for it? So, okay. So if this is clear, what could be the possible workaround which you can think, folks? Which you can think, which comes to your mind? Anything which you can think? Any possible workaround, folks? No, I can will not go with public IP. Will not go with public IP. Shared VPC. How shared VPC is going to help us here? Peering, static route. Static route, something could be possible. What will you peer? Basically, we cannot peer this. We are very clear, right? We cannot peer this. Even if you try, right, it will give you that message. Let me show you. This is my network. This is my project. This is my project. Now let me try to create a peering. It's going to show me an error. So try peering. So network is VPC Taiwan. It is in another project. What is that? Speckle umbrella. That's the project ID. And the network is this one. Let me see whether I have access. Let's see what happens. Now it shows. Now what is the next step? You have to log in to Speckle umbrella 56 project. In this, go to networking, and in peering you have to do this, but you don't have access to this project. So peering is not going to help us in this case. So static route or adding a route information in your table is going to something. Basically the route is missing. Let's accept that the route is missing. That's the only thing which is missing. So if you can do something with your routing table, all those things, more, it's going to be more of networking skills, which is going to make it work. One simple option, if you're not totally from networking, but with the knowledge which we have gained so far, I can do something very simple. Concept of jump host. I first log into Taiwan. From Taiwan machine, I will SSH to London machine, because these two networks are peered. Once I'm in London, I can connect it, right? I can use my London as my jump host or a bastion host. Simple option. This is something which we have seen because it's peering, right? So let me just do that. SSH and show you whether it's going to work or not. This is one possible way, simple, without making lots of routing information changes, all those things. But there is one possibilities which I have seen where you have to do some change to your routing table and all. So now let me copy this one. I'm in server Taiwan, so I'm going to SSH into server Singapore, because I can ping it, I can SSH it. That is possible because they are peered. I'm there. From Taiwan, see, from Taiwan I am into London machine. Once I'm in London machine, copy this IP address. Copy this IP address. Now MySQL -h -u root -p DEMOGCP. I'm there. I'm there. One simplest possible option is using a jump host or a bastion. So then I can do the steps. Another option, maybe at some point of time, if I have some time, I'll create a video on that. So where you have to do basically some networks changes, basically your routing tables, you're going to modify it, and then you should be able to do, because it's all basically the route exists. If the route can be made, we should be able to do it. But you still use the concept of some kind of a bastion host here. Is this part clear, folks? Is this part clear? Because this is a very common question as an interview. The one which I showed you. Where is that? This kind of a stuff. VM in one. And why they do this is something which you would have heard from Vivek last week. Like they want to create a front end in one VPC in network, back end in another network, and that is where this problem comes. And why this comes? Because they come from a different background. They would not have explored how GCP network works. So basically, because of that only this problem comes. So one option, change the networking and explain them VPC in GCP is global. You don't need to have separation. You can play around with tags and service account, or you can use basically a host, a jump host kind of a stuff here. So is this part clear, folks? Any questions on this part? We saw peering, we did it, so it did not work. It did not work, and I have given you the explanation also, I guess, which should be convincing explanation. Basically, the key answer is VPC is non-transitive in nature. Simple. If it is if the interviewer asks you a question, give me a one-word answer, or VPC, because it's non-transitive. That's it. So any questions on this, folks? Let me know, please. If there's no question, I'm going to just delete the Cloud SQL instance.
Mahesh, Vivek this side. This means that any machine of different VPC cannot connect. Like you connected it via manually, but like for the provisioning purpose, they cannot connect. No? This means in automatic.
Sorry, come again.
Means as you show, as a bastion host, we can connect to that machine to the purpose and anything. But like in automated way, like for the provisioning and access, we cannot connect a machine of different VPC and SQL of different VPC. Like
okay, there is one option, but VPC peering will not help you. Basically, there is an option exist, but it's more of networking, where you change, add a routing table, all those, update your routing table and do it. So that is possible. That's going to be totally an automated way. But there, your VPC network peering is not going to come to help, basically. Maybe if some time. So for maintenance and all, if you want, you can do this way. If you want one-time activity, or basically this entire problem arises because of the people thought it in a different way. Database should be separated, front end should be separated. That is the reason why this happens, at least in GCP. At least in GCP, like what last week also you told, right? You wanted it to be in two different network, not subnetwork, two different network or subnetwork. So to avoid that, you can, if it's subnetwork, it's okay, it's going to still work, it's going to still work. But if it's two different network they created, you will have this problem. So then VPC network peering will not come to your rescue. You have to use some networking, more of your networking knowledge, update your routing table, then do it. And I have done it once, it worked actually. I don't remember the command, so after doing some research and all, I made it. It got work. Somewhere it should be there in my documentation. I have to just look for that. But it works. I have seen it.
okay,
is that clear, Vivek? Yeah, I'll try to make a video in the, maybe in the YouTube.
If you could have
seen
this, yeah.
Sorry.
Okay, continue. Someone was asking.
Someone
was about to ask a question, but he just stopped, so he can ask. No issues. I'm done.
Okay. Okay. Yeah. There was a question. Sorry, I did not realize it. Was there a question? Somebody was asking. Any questions, folks? Okay. If there's no question, let me just delete my VMs. So that's something on your private service access. So basically used for Cloud SQL, memory store, and couple of products. Only 3 or 4 products. Maybe why don't I show you the documentation itself? So and there's one new product which is still in beta, Private Service Connect. If I click on this, there are lots of stuff which keeps coming. So it's in preview. So I have not discussed that. Is there a question?
My login with jump host also is not visible solution, right? Because I have to put the IP address.
What is that? Routing?
I mean, login with the jump host IP address not visible solution, right? Because I have to, I mean, explicitly pass the IP address to log into the database.
Sorry, Mangesh. There's some. I'm not able to really understand the question. Little closer to your mic.
Okay. Is it okay now?
Yeah. Tell me.
Yeah. So I mean, previously you log in with IP address, right? That
Log in
MySQL,
with an IP address. Okay.
Yeah. So login with IP address little bit, I mean, not feasible solution, right? Because I have to check the IP address and then, I mean,
You can have an internal DNS. You can have an internal DNS and all. So we have not come to that. You can have an internal DNS if you don't want, or you can use the machine's name, instance name. You can do it. So if you feel okay, IP address is going to change, yeah, that is you can have. You have options there. You have
So
options.
that part is yet to cover, right? I mean,
Yet to be covered. We have not come to.
Okay.
When we talk about DNS, there are two types of DNS. We'll talk about it: public and private.
Okay.
And you can also use the host name. We can also use the host name. We'll talk about that in next week.
Okay.
Yeah. So that is something on private Google. Okay, so I was trying to show you the documentation. So private service connect, it's in preview, hence I did not discuss it. Private Google access, we understood. Private Google access for on-premise host, the same thing is going to apply, meaning you have a virtual machine in on-prem. From that virtual machine, you want to access a Google Cloud storage bucket, but not going via external route. So that's going to be the thing. And the last one is private service access. This is basically for only 4 products or 5 products. Supported is Cloud SQL, memory store for Redis, Memcache, basically memory store products, AI platform training, and cloud build. Only these products only use it. And there's one more thing which we are yet to cover, basically serverless VPC access. We'll talk about that later. So that's something on this. Now, if you see, we are becoming very close or more used to private IPs kind of stuffs, private kind of IPs. And also it may look, maybe the demo which I did just in the past, maybe slightly contradicting, but looks like at least in GCP, you can remove the concept of bastion host. The normal concept of a bastion host, for people who have not used this, usually what people will do is they will have lots of VMs which is going to have internal IP address. Only one bastion host or jump host is going to be there, which is going to have an external IP address. So what you will do is you connect, and this machine is going to be like a gateway, very powerful, hardened, secured. So people connect to this. From this, because once they connect it, it's the same network. From this network, they will access, from this VM, they are going to access the internal VMs, which is going to have only internal IP address. This is how a bastion host works. But with GCP coming into picture, forget the last demo which I showed. Okay, that was slightly out of topic because people asked this question, I showed you. Ignoring the last demo because that was where we actually use bastion host kind of a stuff, but it was using internal IP address, folks, not using external IP address. So um, uh, with the way Google's network is working in such a fashion, I can have a VM with totally internal IP address itself. I can still connect it from my laptop, connect from my corporate environment. I can do everything easily. So at least with Google Cloud, right, looks like the bastion host is going to be absolute. So you don't need it anymore. And it works for Windows, it works for Linux machine very beautifully. So the one which makes this work is actually called as IAP, Identity Aware Proxy, and it's basically a proxy which is going to help you to SSH RDP into Windows and Linux and Windows machine using internal IP address itself. So let me just show you how IAP works. basically what I'm going to show you is a VM with only internal IP address, and give access to this VM to a user, not a owner, some normal user like compute instance admin, something like that. And we'll see how this user is going to able to log in just with internal IP address. And if you try this in other cloud, it may not work because other cloud, for the VM, for you to log in, it should have an external IP address. In Google, it's not required. Basically, with the help of IAP, you can easily achieve it. So how? Let me just show you. And then if time permits, we'll talk about how to reserve an internal IP address, how to reserve, sorry, there's a typo here, how to reserve a external IP address. I'll show you that also. So maybe IAP itself we can do, is my understanding. Let's just see it. VM without external IP address, basically, and I want to SSH. And as Mangesh was asking, IP without IP, can we do anything? Is there any better way? That also I'm going to show you. So first, let me create a VM, folks. VM with only internal IP. VM with only internal IP. Use a template. Cloud identity aware proxy. All default. IAP stands for identity aware proxy. That's the reason I mentioned it here. Identity aware proxy. So what I'm going to do, everything default, but going forward from now, we will never have external IP address, folks. We'll never have external IP address. So this would be the last demo was the last one which we had external IP address. Going forward, we'll make it as a habit. We'll never have an external IP address. So this is the first step towards that. So no external IP address. Done. How do you get updates, patches, install all those things? We have some solution. We'll get better solution next week. So creating a virtual machine with only internal IP address. By the time this comes up, one more virtual machine for one last time with an external IP address, just to compare it. So VM with external IP. Leave all default, create it. By the time the VM comes up, I'm going to go to my IAM, give a user access to this virtual machines, both the virtual machines. So there's no user called Mahesh. Let me add this user, mahesh.com. So I'll just give to a compute instance admin. And because there's going to be a service account, so you should act as that service account. So I'm going to give it as service account user role. Done. Save. So this user should be able to log into this VMs basically. So let's see, the VMs are there, folks. The VMs are there. Now what we are going to do basically is try to log in. One without external IP address, one with external IP address. Now I'm not going to only directly click on SSH. I'm just going to show you an option. Okay, they removed this feature. Okay, I have to go. There was actually a button or option called as view gcloud command. You would have also remembered there was an option, but they changed it. I guess it is inside the VM. When I go here, I should have it. Okay. I don't know why they changed this. Same command, folks. Here, if I do SSH, I don't get that option. But when I go inside the VM, I get view gcloud command. Little funny. I don't know what was the issue. Is it a bug? I'll copy this command. I'll also go to this. I'll also copy this command. Now, what is the difference which you see, folks? The first one is without with identity aware proxy. The second one is with this thing. So the project, I can remove it for now. It's not going to make a huge difference. Now, what's the difference which you see between both the gcloud command? So maybe Mangesh, we can use your machine name itself in this case to SSH. So you're not relying on private IP or the IP address. So what is the difference which you see, folks? Basically, one specifier called as tunnel through. Yes, tunnel through IAP. This is the only specifier which is difference when you do it from your gcloud command. So it's going to create a tunneling. So it's going to create a tunneling basically. That's the first difference which you see. Now, because I'm the owner of this project, I should be able to log in. So if I show, this is the user 28, if you see 2028 is the owner. So for me, both the VMs, whether it is having external IP address or internal IP address, it does not make a difference for me. I can log in and see it. It's going to work for me. Let me just show you that. As an owner, you will not see much huge difference. And that's the reason why in the beginning I told you create an account which is very less privilege and try it. Then you will learn your IAM very well. So I'm in my identity aware proxy VM. Copy this URL, a little bit of hack. Just wanted to share you something, what happens behind the scene. I'm able to log into both the machines. So first machine, if you see, that is your cloud identity aware proxy. Everything is going proper. Okay, this is the one which is everything is same. They changed it. Use admin proxy equal to true. Use admin proxy equal to true. Okay, they are using both. Okay, it is previously there was change, so it's okay. This is not going to be important. Let me remove it. From the gcloud command, you can see the difference. As an owner, I'm able to SSH. Now, I will log in as this user who has only compute instance admin role and service account user role. Now let's see whether how this user can log in basically. So for that, I'm going to go to my Chrome Edge browser. This is Edge. Let me refresh the screen. Just do a retry. Yeah. So now if I show I'm as Mahesh. Now I'll go to my virtual machines. I'll go to my virtual machine. The virtual machine with the external IP address has no issues. I can log in. It works. And you also see this message. Please consider adding IAP secure tunnel user IAM role to start using IAP for port TCP forwarding for better performance. It shows you that message. But I am there. But for my another VM which has only internal IP address, I don't have the option to SSH itself. I don't have that option. And if I try inside, let me see whether I get that button enabled. Here also it is not enabled. Here also it is not enabled. So meaning I cannot even log in. And if you say we know the command line, right? Can you try it? We can. Let me just launch my Cloud Shell. Smart people would be there. They may try to use a command like this. Let's give a try. There's no harm trying it. So if I do gcloud auth list, it is going to show Mahesh. So I have only compute instance admin role and service account user role. Now let me see if I use this command, is it going to work? And I'm not using an IP address here, I'm using the machine's name. All right, you get an error saying that beta compute is trying, but it is getting unauthorized. IAP tunnel, something related to some tunneling, we don't have the necessary access. So basically, this is where IAP comes into picture. So if it's a user who is not a owner, editor, compute admin kind of roles, but it has a lesser role and you want to allow him or her to log into a VM with internal IP address, how do you do that is, that's where identity aware proxy comes into picture. So I'm back as my owner. I will go to my IAM identity aware proxy. So if I click on this, you get this identity aware proxy lets you manage who can access a given service hosted on an app engine, compute engine, or HTTPS load balancer. So now the focus is on SSH. We'll talk about HTTP resource later. So I'm going to click on this tab, SSH and TCP. Now what does it show is basically my configuration is already enabled, meaning I just need to enable my API. It's going to be showing like this. If I just click on this VM specifically, you see only owner can easily log in for the specific access for this VM. Now, if I add a user, Mahesh, the role which I have to give is secure tunnel user. Remember when you were SSHing into it, it was showing you a small message. Turn on this. This is what you are going to do. So secure tunnel user. Done. Now, if I swap my screen to my Edge browser, refresh the screen, the SSH should be enabled. So let me just refresh it. Let me refresh it one more time. Not reflecting. Let me try going inside it and see whether it is reflecting. Okay, it works here. They made it as a, is it reflecting? 1 minute. Okay, it is now reflecting. So now I can see the options. Previously it was disabled just because I have enabled the IAP secure tunnel. What was that role? Tunnel user. I'm able to tunnel through and I should be able to connect. So let me just SSH just to show you I'm back in Mahesh as a Mahesh user. SSH. I'm logging into my testing. Yes, I see it. So I cannot ping anything. I cannot ping anything. Which is Google, but I'm able to SSH into it. So it's the same command you use, the same gcloud command you use it from your local machine, it's going to also work. So I don't need a external IP address with private Google, with identity aware proxy turned on. I don't need it. I don't need it. So let me show you one more demo and stop it for the day. Create one more VM. It's going to be a copy of this. It's a copy of this. So I'm going to click on similar. Clone. So let's wait for this to come up. So because I'm the owner, SSH is going to be there. But now if I go back as Mahesh and refresh this, the problem comes back again. For this user also, I will not have anything. For this VM also, I will not have it. So what I should do, basically, go back to your identity aware proxy. Go back to your identity aware proxy, add this user. Add this user. So here, if you see the clone, it's not going to have it. So you have to add every time. Only then that for that specific VM, the user will get access to. This is one possible way of doing it. Assume you want to give Mahesh all the VMs access to SSH to all the VMs in this project with internal IP address. What is that which you are going to do for Mahesh, folks? What is that step which you should do? And I don't want to do every time this. Create a VM, I come add here. I don't want to do it. Is there any better way where in one place you do it so that it's going to apply for all the VMs Mahesh is going to create using SSH for that specific user? What is that which you can do? Hope the question is clear. I don't want to do it for every VM. Come to IAP, set, add the tunnel user. I don't want to do that. Secure tunnel user. How do I avoid this, folks? How do I avoid this? You answer it, we stop for the day. Is the question clear? I don't want to do this again and again. How can I avoid this? I'm doing it at a particular VM level by clicking on show info panel. Individual VM level. If it's for individual VM only, for example, for clone, I want to give it to somebody, for something else, I want to give to somebody, then this option works. But there's one common user for every VM, he should get access. Or there's a group which should get access. What will I do? Should be very simple, folks. Back to your IAM question. That's it. Answer is simple. Let me just remove this user here, first of all. If you can keep if you want, I'm just going to remove him. Done. So Mahesh will not have access itself. So if I just go back, refresh it, just setting up the stage proper here. So I'll show you. So he will not have access to both the VMs. Both the VMs, he does not have SSH. And I have logged in as Mahesh. Now, basically, you should get to all VMs. What I do basically is go to my IAM, Along with compute instance admin role, service account user role, I'm going to give him secure tunnel user role. That's it. So that for every VM which is getting, he's going to have it. Simple, right? So let's just give a try whether it's going to work. IAP, okay, I need to search. IAP secure tunnel user. That's it. That's it. I have added. This is going to be applied at an entire project level. Go back, refresh it. Let's see whether it is going to show up or not. Simple, right? It is the same concept which you learned, folks. I asked the question, this side, that side. You should be able to get it. That's it. So it's not reflecting. Let me just refresh it one more time. Same question asked in different forms. It's not reflecting. Let me just see it one more time. Or let me just go inside it and see whether it shows up. Okay, it shows. It shows. Looks like a bug in the UI. Okay, it shows. Now I can log into clone machine, or to my other virtual machine. I'm there in my clone machine and also in my other machine. So this is where the identity aware proxy with respect to SSH works, folks. There's one more option which we will explore during our load balancer class, where we will use HTTP load balancer. At that time, we'll see the HTTP resource part of it. So now you see private IP is not required. Sorry, public IP is not required. So I can do everything with private IP address itself. So it's going to be really a cool option which you can leverage. So I personally have done projects where the compute engine, Kubernetes engine will never have an external IP address. Everything is internal. The only place it's going to have an external IP address is a load balancer. That's it. Nowhere else I'm going to use external IP address. So that is the kind of implementation which you should usually do. Okay, so with that, let me stop it here. Next week, when we resume back, we'll talk about what is internal IP reservation, external IP reservation. Is that internal IP reserving is going to charge us, external IP reserving is going to charge us or not? We are going to see it in next class. At that time, we'll also talk about one more concept called as alias IPs. We have not talked much about IP. So we have seen internal IP is going to be helpful, but how we can reserve it, all those things, and why should you reserve it, all those things we'll explore it in our next class. Let me stop it here. If you have any questions, happy to answer, folks. Any questions? Any questions, folks? No questions? Okay. We have to set up servers that have shared mount point. Okay. We have two servers that have a shared mount point, NFS with Linux file system, which can read write from both the servers. Can same be done over GCP or over compute engine? That's where you're going to use basically your file store. We had seen, right, Mangesh? So sorry, Aman, file store, which is an NFS file system. This product, if you use Aman, you should be able to do it, but it's an expensive product. But what you want, you can do it here with this option. So for Vivek, networking should not be tough, Vivek. I've seen your responses. It's good. I don't think so. It should be difficult for you. So use file store. It should be going to be fine. Yeah, Vivek.
Just started preparing for network engineer actually from yesterday, but I found it very difficult. During the first class, you asked me, which one is the toughest class you feel section. I say networking is the toughest one, which I feel. For me, networking is the toughest, and IAM. Both section are very, very tough for me.
Okay. But to be very frank, folks, when I took my network engineering certification, I did not even prepare. The only reason is my organization in which I was working, I was doing too much of networking, cloud architect networking stuff. I just went directly to the examination center and took the exam actually. So, so nothing beats your real experience. So if you don't need to prepare usually. So I saw that in two instances. Network engineering, after few months I took security engineer also. It was the same thing because that customer's project was that so strong, and the DevOps person with whom I work, he was very particular. Everything has to be internal. So that project which I worked was very helpful for me to clear my network engineering and security engineer very easily. So that's one thing which made my networking skills very easier. So I would say, Vivek, if you feel like it is little this thing, think of all possible options, do practice, do all the kind of stuffs. Now that's the best way I would say. So if you feel something difficult, IAM is difficult or confusing, if you say, make yourself, you will definitely, when you create an account, you will be the owner. Now create one more Gmail ID, give that Gmail ID the least privilege it can give. Then start doing all the demos which we are doing. Then you will really understand how IAM works. Give him browser role, the second user. Then start creating VM. So you'll get error. Now you'll know what role you have to give. Start creating VPC. Then you'll know you should have compute network admin role. So that way your IAM is going to increase better. Need lots of hands-on on practice on. Yeah, that's basically the stuff. I always do anything on networking, do it and understand. That's how I understood the networking, because I'm also not from a networking background. So the only thing which I was knowing was what is an IP address. That's the only thing. And ping command. Nothing else I was using before coming to GCP. But now I understand how VPN works, peering works, all those things. It was only because of practice. All right, folks, if there's no more questions, we'll stop it for the day. I'll send you the recordings. See you on next week. Next week, we'll explore on internal IP, external IP, and secondary IP address. All right. Thank you, folks. Thank you. Bye.